Good evening everyone, good evening. I welcome you all again to NEET Elite. I hope all of you are doing great, having a good time. So people, you can first of all let me know in the chats, right? You can give me some green signal from the chat box so that I'll get to know that I'm audible and visible to everyone, right? Hello Ashwarya, hi Aisha, hello Kailash, hello Shamira, hi Ishpreet, hello Meenal, hello Yuvashri, hello Dakshin, hello Harsha, hi Saqib, walaikum salam, hello Ishrat. Welcome back everyone. Just give me some green signal from the chats first of all so that I'll get to know that I'm audible and visible to you guys properly. Yes? Let me know fast in the chats. Right? I'm doing great, Ashwarya, I'm doing great. Just give me a second, guys. Let me fix the things. Just a second. Just a second. Okay. So people, as you all must be knowing, tonight it's going to be our third session from the chapter Mole Concept, right? And in the tonight's session, what we are going to do, if you remember in the last session, we started the topic called as Stoichiometry, right? In the tonight's session, we will be continuing the Stoichiometry topic. Apart from that, we'll be talking about the mixture analysis, right? The problems which are based on the analysis of the mixtures. We'll be talking about the principle of atomic conservation, and at the end, if we get some more time, right, we'll be talking about the limiting reagent as well, okay? So these are the topics which I'm going to cover in the tonight's discussion, okay? And I might sound a bit low tonight because I'm not well, yeah? Okay, so I hope it's fine for you. So before starting the session, the ones who have just joined in, who are new to the channel, let me introduce myself. Well people, my name is Wassim Sir and I'm your chemistry master teacher right here on this NEET Elite channel, right? Well, the ones who have not liked the video yet, please do like the video, share the video with friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this NEET Elite channel, right? So do like the video, share the video with friends, and do subscribe to the channel as well. Yes? Perfect. So first of all, you guys can let me know in the chats if you all are super duper excited about the tonight's session as well, right? Just let me know. Yes, Aisha, I've got a bit of cold, cough, and fever at the same time, right? But I'm not COVID positive. Yes? Okay, so you guys can let me know in the chats if you all are super duper excited for the tonight's session as well, right? Let me see the Josh of the session. Right? Okay, that's perfect, guys. That's perfect. That's perfect. All right. So let's get going then. Let's get started with the topic stoichiometry, which we started in the last session, right? And we'll be trying to understand this stoichiometry in a better way by doing some good problems, right? And the first question, which is going to be on your screen over here. See guys, just have a look on the question. See how these sort of questions are to be solved by using the stoichiometry, right? Read the question first. Calculate the volume of carbon dioxide liberated and the volume of oxygen consumed during the combustion of 128 grams of methane at STP. First of all, as per the question itself, what we guys are doing, we are doing the combustion of methane, right? Basically, we are making this methane to react with the excess of oxygen. And you all must be familiar with the fact what are going to be the products of this combustion reaction? The products are going to be definitely carbon dioxide and water. Right, people? Now have a look how this sort of a question is to be solved. First of all, as per the question itself, we are doing the combustion of methane. So CH4, I'm making it to react with the excess of oxygen, and the products in this reaction are definitely going to be carbon dioxide and water. So first of all, I wrote the reaction. Now what do I need to do? I need to balance the reaction first. Since the reaction is not balanced, so let's try to balance this reaction first of all. And in the last session itself, I told you exactly how to balance the combustion reactions. So the stoichiometric coefficient of carbon dioxide you'll be writing as 1. The stoichiometric coefficient of water you'll be writing as 2. And the stoichiometric coefficient of O2 you'll be writing as 2 again. The reaction would have got automatically balanced, right? This is a balanced chemical equation now. Well, after balancing the reaction, what you need to do is, let's convert the given quantity into number of moles. Basically, we are doing the combustion of 128 grams of methane. So mass of methane is given to me as per the question. So what I'll be doing, first of all, I'll be calculating the number of moles of methane. I'll be converting the given quantity into number of moles. So number of moles of methane will be equal to given mass of methane, which is 128 grams, divided by molar mass of methane, that is 16, right? What is going to be the value which will come out to be from here? The value is going to be 8, right? So basically 128 grams of methane means we have got some 8 moles of methane, right? The first part of the question, calculate the volume of carbon dioxide liberated. Calculate the volume of carbon dioxide liberated by the combustion of 128 grams of methane. As simple as that. Have a look exactly. Over here, the stoichiometry coefficient of methane is 1. And as you can see over here, the stoichiometry coefficient of carbon dioxide is again 1. So by using the mole-mole analysis, by using the stoichiometry, I can say 1 mole of methane, it gives 1 mole of carbon dioxide, right? As simple as that. 1 mole of methane gives 1 mole of carbon dioxide. Well, people, if 1 mole of methane is giving 1 mole of carbon dioxide, can I say 8 moles of methane on combustion will be giving 8 moles of carbon dioxide? So first of all, I got to know the number of moles of carbon dioxide which are getting liberated as per the equation. As per the equation, 8 moles of carbon dioxide are getting liberated. But am I supposed to calculate the moles of carbon dioxide liberated? No, I'm supposed to calculate volume of carbon dioxide liberated. How do we convert moles into volume at STP? You all know this. Volume of carbon dioxide liberated at STP will be equal to moles of carbon dioxide liberated multiplied by 22.4 liters. Just you need to solve this. You will be getting the volume of carbon dioxide liberated at STP, and some of the people are saying it's coming out to be 179.2. So I trust you. So it's going to be 179.2 liters. So 179.2 liters of carbon dioxide are basically getting liberated as per the equation, right? So the first part of the equation is done. You have calculated the volume of carbon dioxide liberated, correct? Now what about the second part of the equation? The second part of the equation says calculate the volume of oxygen consumed in the reaction. Calculate the volume of oxygen consumed in the reaction. Let's try to calculate the volume of oxygen consumed in this reaction, right? Let's try to calculate the volume of oxygen consumed in this reaction. Have a look. Again, what I'll be doing, I'll be using again the mole-mole analysis. I'll simply say 1 mole of methane, now I'm using the term reacts with. 1 mole of methane reacts with 2 moles of carbon dioxide as per the stoichiometry of the reaction is concerned, right? 1 mole of methane reacts with 2 moles of oxygen, right? Yes. If 1 mole of methane is reacting with 2 moles of oxygen, can I say 8 moles of methane? Can I say 8 moles of methane are going to react with 2 multiplied by 8 moles of oxygen? So you got to know exactly the number of moles of oxygen which are being consumed in the reaction, right? So the number of moles of oxygen consumed in the reaction will be equal to 16, right? So in this reaction, some 16 moles of oxygen are being consumed, right? But was I supposed to calculate the moles of oxygen consumed? No. I was supposed to calculate the volume of oxygen consumed. So I'll say volume of oxygen consumed in the reaction will be equal to moles of oxygen consumed multiplied by 22.4 liters. Just calculate it, solve it, you'll be exactly getting the volume of oxygen consumed in the reaction. And majority of the students are saying it's coming out to be 358.4 liters, right? So it's going to be 358.4 liters. So these many liters of oxygen are being consumed in this reaction, right? You guys can let me know in the chats if it is clear to everyone so that I can move on to one more, yeah? And the ones who have not liked the video yet, please do like the video, share the video with the friends, and do subscribe to the channel as well. Yes? Let me know fast. Let me know fast. Is it clear to everyone? Yeah? Perfect. So let's move on to one more type of question. Let's move on to one more type of question from the stoichiometry. See guys, this is one more type of question which can be asked from the topic stoichiometry. But before solving this question, it's a very simple question first of all, right? But before solving this question, let me tell you some basic things. Let me talk about certain basic things over here, right? So that you can understand, you can solve these type of questions properly, yeah? See guys, exactly what I'm going to talk about, right? For example, if I take 1 mole of H3PO4, let's say I take 1 mole of H3PO4, right? Can I say first of all, 1 mole of H3PO4, it contains 3 moles of hydrogen atoms. 3 moles of hydrogen atoms, absolutely. It contains 1 mole of phosphorus atoms. 1 mole of phosphorus atoms. It contains 4 moles of oxygen atoms as well, right? Absolutely, absolutely. I can say 1 mole of H3PO4, it contains 3 moles of hydrogen atoms, 1 mole of phosphorus atoms, and 4 moles of oxygen atoms, right? Similarly, if I take, for example, 1 mole of H2SO4, 1 mole of H2SO4, can I say something like this? 1 mole of H2SO4, it contains 2 moles of hydrogen atoms. Absolutely, it contains 2 moles of hydrogen atoms, right? Can I say it contains 1 mole of sulfur atoms? Yes. Can I say it contains 4 moles of oxygen atoms? Right? Okay. Can I say something like this as well? See, can I say something like this as well? I told you 1 mole of H2SO4, it contains 2 moles of hydrogen atoms. 2 moles of hydrogen atoms, right? If I ask you something like this, how many hydrogen molecules, if I ask you how many hydrogen molecules are present in 1 mole of H2SO4, you will say 1 mole of H2SO4 contains 1 mole of hydrogen molecules. Contains 1 mole of hydrogen molecules, right? If I ask you 1 mole of H2SO4 contains how many moles of oxygen molecules, you will say it contains 2 moles of oxygen molecules, O2 molecules, right? I'm sure this part is clear to you. I'm sure this part is clear to you, right? Now, if you got these 2 things, let's try to solve this very simple and basic question, right? Have a look exactly how do we approach this. Understand. Calculate the number of moles of oxygen atoms. So basically you are supposed to calculate the moles of oxygen atoms. You are not supposed to calculate the moles of oxygen molecules. You are supposed to calculate the moles of oxygen atoms in 3.2 grams of Na2SO4.2 times water, right? Well, the molar mass of Na2SO4.2 times water is given to me as 178 grams per mole, right? First of all, this is the given quantity, 3.2 grams of Na2SO4. Let me convert the given quantity into number of moles, right? So number of moles of Na2SO4.2 times water, right? It is going to be equal to given mass of the substance, which is 3.2 grams, divided by molar mass of the substance. So these many moles of Na2SO4.2 times water we have, right? Understand. Now, if I take 1 mole of Na2SO4, if I take 1 mole of Na2SO4.2 times water, can I say 1 mole of Na2SO4.2 times water, it contains 4 and these 2. It contains 6 moles of oxygen atoms. It contains 6 moles of oxygen atoms, right? I can say 1 mole of Na2SO4.2 times water, it contains 6 moles of oxygen atoms. But do I have 1 mole of Na2SO4.2 times water with me? No. I have got these many moles of Na2SO4.2 times water with me. If 1 mole of Na2SO4 contains 6 moles of oxygen atoms, so I must say 3.2 divided by 178 moles of this substance will be containing 6 multiplied by 3.2 divided by 178 moles of oxygen atoms, right? Moles of oxygen atoms. Now it's going to be your turn to do the calculation part of this one. You'll be getting exactly the number of moles. Well, Chandan is saying the answer is coming out to be 0.01, right? 0.017. Is that? Should I be trusting you on this? 0.108 someone is saying. Okay. 0.10 something. All right. So this value after solving, you are getting it as 0.108. So what does it mean exactly? It simply means these many moles of Na2SO4.2 times water contains these many moles of oxygen atoms, right? But in the question, if it was asked like this, if the question was asked like this, calculate the number of moles of oxygen molecules, right? If the question was asked like this, calculate the number of moles of oxygen molecules. At that point of time, you would have written something like this. 1 mole of Na2SO4.2 times water contains 3 moles of oxygen molecules. Contains 3 moles of oxygen molecules. So these many moles will contain 3 multiplied by 3.2 divided by 178 moles of oxygen molecules, right? Okay, that would have been the answer of the question if it was asked that calculate the number of moles of oxygen molecules. I'm sure you're clear with both the things, right? Right, my dear elites? Perfect. Let me directly jump in to one more question so that you can understand this concept properly, right? See guys, look at this question. Look at this question. These are basically 2 questions, right? These are basically again 2 questions and you guys are going to give it a try. Have a look exactly how do we approach to these sort of questions. The question says, calculate the mass of H2SO4. Calculate the mass of H2SO4, which contains, number 1, 0.25 moles of oxygen atoms, right? You need to see exactly that mass of H2SO4 which contains 0.25 moles of oxygen atoms. You need to understand the language of the question first. You need to understand the language of the question first, right? I need to calculate the mass of H2SO4 which contains 0.25 moles of oxygen atoms. See exactly how this sort of a question is to be solved. Understand properly, yeah? Have a look. First of all, if I take 1 mole of H2SO4, if I take 1 mole of H2SO4, can I say 1 mole of H2SO4, it contains 4 moles of oxygen atoms? Absolutely, you can write a statement like this in simpler ways, right? 1 mole of H2SO4 contains 4 moles of oxygen atoms, right? What I'll be doing, if I just reverse the statement, can I say 4 moles of oxygen atoms, 4 moles of oxygen atoms, now I'm using the term, are present in, right? I'm saying 4 moles of oxygen atoms are present in 1 mole of H2SO4, right? 1 mole of H2SO4, absolutely I can say something like this. 4 moles of oxygen atoms are present in 1 mole of H2SO4. If I ask you, what about 1 mole of oxygen atoms? I can say 1 mole of oxygen atoms will be present in 1 divided by 4 moles of H2SO4, right? If 1 mole of oxygen atoms are present in 1 by 4 moles of H2SO4, what about 0.25 moles of oxygen atoms? Can I say 0.25 moles of oxygen atoms will be present in 1 by 4 multiplied by 0.25 moles of H2SO4, right? Instead of this 0.25, I'll be writing 1 by 4, right? So 1 by 4 multiplied by 1 by 4 comes out to be 1 by 16. So what did I get over here? Can I say I got those moles of H2SO4, these are the moles of H2SO4 which contain 0.25 moles of oxygen atoms. I got the moles of H2SO4 which contains 0.25 moles of oxygen atoms, right? So these many moles of H2SO4 contain 0.25 moles of oxygen atoms, right? But am I supposed to calculate moles of H2SO4 ke mass of H2SO4? I'm supposed to calculate the mass of H2SO4. Well, you got the moles of H2SO4. Now you can convert it into mass as well, right? You can say mass of H2SO4 which contains 0.25 moles of oxygen atoms will be equal to moles of H2SO4 multiplied by its molar mass, as simple as that. Moles are 1 by 16, molar mass of H2SO4 is 98 grams per mole. Just solve this value, this is going to be your answer, right? This is going to be your answer, as simple as that. Right, people? So Ishpreet is saying the answer is coming out to be 6.125. All right, I trust you all. 6.125 grams. What does it mean? What does it mean? It simply means 6.125 grams of H2SO4 will be containing 0.25 moles of oxygen atoms, which I was supposed to calculate as per the question, right? You guys can let me know in the chat if it is clear to everyone, so that I can move on to the second part of the question. And I'm sure second part of the question you can solve on your own, right? Second part of the question, absolutely you guys can solve on your own. Should I be giving you the second part of the question as the homework? Can you do it? Can you do it, my dear elites? Yeah? Can you do the second part of the question on your own? Right? The concept is same. In the similar way, you are going to solve the second part of the question. Yeah? So do give it a try and let me know its answer in the comment section afterwards when this session ends. Right? do let me know its answer in the comment section, and I'll be checking exactly who all did the question and who all got the question right. Yeah? Perfect? Okay, let's move on to a few more. Just a second. Okay. This is one more similar type of question, and this question was asked in your JEE Mains long back, right? And this is a proper NEET standard question as well. The similar type of question, right? Some of you might be remembering its answer as well, right? Because this has been asked many a times in different competitive examinations. That's why deliberately I've come up with this one. Sir, your voice is cracking. Is that? Guys, am I audible and visible to you guys? Am I audible and visible to you properly? Am I perfectly audible? All right, okay. Okay. All right, so majority of the students are saying your voice is clear. So let me go with the majority. Okay, let's exactly see now how this sort of a question is to be solved. See guys, again a similar type of question, right? Have a look. Calculate the mass of H3PO4 which contains 0.25 moles of oxygen atoms, right? In the similar way, I'm going to solve this question. First of all, if I talk about 1 mole of H3PO4, can I say 4 moles of oxygen atoms? Can I say 4 moles of oxygen atoms are present in 1 mole of H3PO4? Absolutely, I can say something like this, right? Right, people? 4 moles of oxygen atoms are present in 1 mole of H3PO4. Can I say 1 mole of oxygen atoms will be present in 1/4 moles of H3PO4? Absolutely, right? So can I say 0.25 moles? Can I say 0.25 moles of oxygen atoms will be present in 1/4 multiplied by 0.25 moles of H3PO4? Instead of 0.25, I'm writing again 1/4, so the value comes out to be 1/16. So what is this 1/16? Basically, these are the moles of H3PO4 which contains 0.25 moles of oxygen atoms, right? But was I supposed to calculate the moles of H3PO4 or mass of H3PO4? I need to calculate the mass of H3PO4, right? So I'll be writing the mass of H3PO4. The mass of H3PO4 which contains 0.25 moles of oxygen atoms. It's going to be equal moles of H3PO4 multiplied by molar mass of H3PO4, which is 98 grams per mole. So the value will be, I guess, 12 point something, right? Is it 6 point something? 6.125, yeah. 6.125 grams. So this is going to be the mass of H3PO4 containing 0.25 moles of oxygen atoms. People, is it clear to everyone? I'm sure this question will be clear to everyone, right? You can solve these sort of questions from now onwards. I'm sure about that now. Should I be moving on to one more? Let me know fast in the chats. All right. So let's move on. This is one more question, right? Let's try to solve this sort of a question as well. Whatever questions we have solved till now, we have solved all the questions by means of mole-mole analysis, right? We haven't solved any question by mass-mass analysis yet, right? Let's try to solve the questions by using stoichiometry, but through mass-mass analysis, okay? Right? Understand what that means exactly. Have a look. See guys, first of all, I'll be writing the reaction that's given to me. And the reaction is given in the balanced form, as you can see, 3 times NO2 plus H2O. It gives 2 times HNO3. And at the same time, it gives NO as well. This is the reaction, this is a balanced chemical equation that's given to me, right? As per the question, how many grams of NO2? How many grams of NO2? That means I'm supposed to calculate the mass of NO2. How many grams of NO2 are required to produce 25.2 grams, are required to produce 25.2 grams of HNO3, right? How many grams of NO2 are required to produce 25.2 grams of HNO3, right? So basically, I'm supposed to calculate the mass of NO2 which is required to produce 25.2 grams of HNO3. 25.2 grams of HNO3. So basically I'm going to relate just two things in this reaction. I'm going to relate NO2 with this HNO3. That's all. I've got nothing to do with this water. I've got nothing to do with this NO as well, right? I'm just going to relate these two, as simple as that, okay? Now let's try to solve this question by using mass-mass analysis. Have a look how I'll be approaching to this sort of equation. First of all, if I ask you, what is the molar mass of NO2? Nitrogen has got the molar mass of 14 grams, O2 has got 32, so 14 plus 32 comes out to be 46, right? So 46 grams is the molar mass of NO2, yeah? Or I can say 46 grams is the mass of 1 mole of NO2. But do I have 1 mole of NO2 or 3 moles of NO2? I have 3 moles of NO2, right? So what is going to be the mass of 3 moles of NO2? Isn't it going to be 46 multiplied by 3 grams? This is the mass of 3 moles of NO2, as simple as that. And this value will come out to be 3 6 are 18, 3 4 12, 138, right? So the mass of 3 moles of NO2 will come out to be 138 grams, correct? If I ask you, what is the molar mass of HNO3? You'll clearly say the molar mass of HNO3, when you calculate it, it will come out to be 62 or 63. I think 63, right? 63 grams is the molar mass of HNO3. What does that mean? That means mass of 1 mole of HNO3 is 63 grams. But do I have 1 mole of HNO3 or 2 moles of HNO3? I have 2 moles of HNO3. So if mass of 1 mole of HNO3 is 63 grams, mass of 2 moles of HNO3 is going to be 63 multiplied by 2. That means 126 grams. As simple as that. Now have a look. See how am I going to approach to this sort of equation. What do I need to calculate? I need to calculate the mass of NO2. I need to calculate the mass of NO2, right? So I'll try to write the statement in such a way that NO2 comes on the right hand side. Do remember, whatever quantity you're supposed to calculate. Okay, for example, you are supposed to calculate mass of NO2, you are supposed to calculate mass of water, you are supposed to calculate mass of HNO3, whatever you are supposed to calculate, that part you are always going to write on the right hand side. That part you are always going to write on the right hand side. And how come? Have a look. I'll say 126 grams of HNO3. I'll say 126 grams of HNO3 as per the stoichiometry are produced from 138 grams of NO2. Yeah, I can say something like this. Why did I write NO2 on the right hand side? Because I need to calculate the mass of NO2 as per the equation, right? Okay, so that's why I wrote the NO2 on the right hand side. Yeah, now have a look. 126 grams of HNO3 are produced from 138 grams of NO2. So can I say 1 gram of HNO3 is produced from 138 divided by 126 grams of NO2, right? So I got to know 1 gram of HNO3 is produced from these many grams of NO2. If 1 gram of HNO3 is produced from these many grams of NO2, so 25.2 grams as per the equation, 25.2 grams of HNO3 should be produced from 138 divided by 126 multiplied by 25.2 grams of NO2, right? What did I calculate exactly? This is basically that mass of NO2, which is required to produce 25.2 grams of HNO3, which I was supposed to calculate as per the equation. Absolutely, people are saying we are getting this value as 27.6. All right, so what we got to know exactly? We got to know 27.6 grams of NO2 are required to produce 25.2 grams of HNO3 as per the equation, right? You guys can let me know in the chats if it's clear to you so that I can jump into one more question. Yeah? Is that clear? Is that clear, my dear leads? Fast. Is that clear? Okay, moving on to one more then. One more. Okay, this is one more question, and this question is again the question based on the stoichiometry, and I would be solving the same question. I will be solving this question again by using mass analysis, right? By using mass analysis, correct? Now, have a look. How will I be solving this question? First of all, let's write the reaction again. See, the reaction is given to me in the balanced form, right? If the reaction was not given to me in the balanced form, my first step always would be to balance the reaction. Since the reaction is given in the balanced form, so I'm not supposed to balance it again, right? It's in the balanced form. But if it was not in the balanced form, I was supposed to balance it, right? So let me write the reaction again. The reaction is 4 times HCl plus MnO2 plus MnO2. It gives MnCl2. With this, you are writing 2 times water, and with this, you are writing Cl2 as well. This is the reaction which is given to me, right? Now read the question carefully. How much HCl is needed? How much HCl is needed? So you are supposed to calculate the mass of HCl in grams. You are supposed to calculate the mass of HCl as grams. How much HCl is needed for complete reaction with 69.6 grams of MnO2, right? What does that mean? You need to see what is going to be the mass of HCl which is needed to completely react with 69.6 grams of MnO2, right? Molar mass of MnO2 is given to us, right? So what I need to calculate? I need to calculate the mass of HCl. If I need to calculate the mass of HCl, while writing the statement, I'll be writing the HCl on the right hand side, right? That's what we do. Since I need to calculate the mass of HCl, so I'll try to write the HCl on the right hand side, yeah? Perfect. Have a look exactly. First of all, if I use the mass analysis, if I ask you what is the molar mass of HCl, you'll clearly say the molar mass of HCl is 36.5 grams. Molar mass of HCl, that means mass of 1 mole of HCl is 36.5 grams. But currently we have 4 moles of HCl. So what is the mass of 4 moles of HCl? It's going to be 36.5 multiplied by 4. So these many grams of HCl we have over here, right? What about the molar mass of MnO2? Molar mass of MnO2, as per the equation, it's given to me as 87 grams. What does that mean? That means mass of 1 mole of MnO2 is 87 grams. Oh, and over here we have got 1 mole of MnO2, so its mass is 87 grams. We need to calculate what? As per the equation, we need to calculate the mass of HCl, correct? So while writing this statement, I'll write the HCl on the right hand side, right? So I'll simply say, as per the stoichiometry, by using mass analysis, 87 grams of MnO2 completely reacts with 36.5 multiplied by 4 grams of HCl. Yeah? This is something which I've written. Okay? 87 grams of MnO2 completely reacts with these many grams of HCl. So can I say 1 gram of MnO2 reacts with 36.5 multiplied by 4 divided by 87 grams of HCl? As simple as that. Okay, so I got to know 1 gram of MnO2 reacts with these many grams of HCl, right? But do we have 1 gram of MnO2 with us? No. We have got some 69.6 grams of MnO2 with us. So if 1 gram of MnO2 is reacting with these many grams of HCl, can I say 69.6 grams of MnO2 reacts with 36.5 multiplied by 4 divided by 87 multiplied by 69.6 grams of HCl. So what did I calculate? So this is basically the mass of HCl which is needed to completely react with 69.6 grams of MnO2, which is something I was supposed to calculate as per the equation. And people are saying the value is coming out to be 116.8. So this value after solving, you are getting it as 116.8 grams. So what is this 116.8 grams? This is basically that mass of HCl which I need to take. Right? This is that much mass of HCl which is required to react completely with 69.6 grams of MnO2. Right? You guys can let me know in the chats if it's clear to everyone. Right, people? You guys can let me know in the chats if it is clear to everyone so that I can move on to one more. And again, the ones who have not liked the video yet, do like the video, share the video with friends, and do subscribe to the channel as well, my dear elites. Yeah? Exactly, Thomas. You can solve the same question by means of mole analysis as well, right? It's completely your choice to opt the method. Yeah? Perfect. So let's move on. Let's talk about the questions which are based on the mixture analysis, right? Okay. Well, in the mixture analysis questions, you need to use a bit of your brain. Yeah? Right? Okay. The mixture analysis, these are the particular set of questions which I'm going to show you now, right? Okay. Let's see how exactly the questions can be solved which are from the mixture analysis. Okay. Let's have a look, guys. The first question which I've taken over here. Look at the question carefully. And whatever steps I'll be following, you guys are going to follow the same steps, right? Have a look. The question says we have got 1 gram of an alloy of magnesium and aluminium. So what does that mean exactly? That means you have got a container, and in the container you have got a mixture containing magnesium and aluminium. And the mass of this mixture is given to me. It's given to me as 1 gram. Mass of this mixture is given to me as 1 gram, right? Okay. So 1 gram of an alloy of magnesium and aluminium reacts with HCl to produce 1.12 liters of H2 gas at STP. Calculate the composition of the alloy. Have a look exactly how am I going to solve this sort of equation. We have got 1 gram of a mixture containing magnesium and aluminium, right? Now in this container, you are adding HCl as per the equation. As per the equation, you are adding some HCl. When you put HCl into this container, as per the equation, 1.12 liters of hydrogen gas is being liberated at STP, right? As per the equation, when you put HCl into this mixture, what is happening? H2 gas is liberating. And what is the volume of H2 gas which is getting liberated? 1.12 liters of H2 gas is being liberated at STP. What do you need to calculate? You need to calculate how many grams of magnesium and aluminium are there in the mixture. That's something you need to calculate. You need to calculate the mass of magnesium and aluminium which is there in the mixture. See exactly how do we approach to this sort of equation. Understand. First of all, when HCl is put into this container, what is the volume of H2 which is liberating as per the equation? 1.12 liters. Can you let me know how many moles of H2 are being liberated as per the equation? Since we are given with the volume of H2 gas being liberated, I'll be dividing it with 22.4. So these are basically the total moles of H2 gas which are being liberated, right? Which are being liberated as per the equation itself. These are the total moles of H2 gas which are being liberated as per the equation. Now, when you will put HCl into this container, can I say some part of HCl will be reacting with magnesium and the remaining part of HCl will be reacting with aluminium? As simple as that. Since you are putting HCl into this container, so some part of HCl will be reacting with magnesium and the rest of the amount of HCl will be reacting with aluminium, right? Let's assume there were some X grams of magnesium in the container. If there were some X grams of magnesium in the container, can you let me know the mass of aluminium which is there in the container? So that is simply going to be 1 minus X grams, right? This is something which I've assumed. Let's assume there are X moles of magnesium in the container. So there will be 1 minus X grams of aluminium in the container, right? If I divide this X by the molar mass of magnesium, and at the same time, if I divide this 1 minus X with the molar mass of aluminium, what did I get? Now these are not grams. Now this X by 24, these are the moles of magnesium in the container. Similarly, now these are the moles of aluminium in the container, right? Now, these are the moles of magnesium in the container and these are the moles of aluminium in the container, right? Now what is happening? You are putting HCl into this container and as I told you, some part of HCl will react with magnesium and some part of HCl will react with aluminium, right? And you must be knowing when magnesium reacts with HCl, what is going to be the product? The product is going to be MgCl2 and with this MgCl2, H2 gas will be liberated, right? Similarly, when some part of HCl, when the remaining part of HCl reacts with aluminium, what is going to happen? When aluminium is going to react with HCl, what is going to happen? The reaction will take place and AlCl3 gets formed and with this H2 gas gets liberated. So these are basically the two reactions which will be taking place when HCl is added into this container, right? These are the two reactions which are taking place when HCl is being added into this container. Some part of HCl reacted with magnesium and the remaining part of HCl reacted with aluminium, right? Okay. So these are the two reactions which are taking place basically, right? If you look at the reaction number 1, from this reaction number 1, H2 gas is being liberated. From this reaction number 2, H2 gas is being liberated, right? So these were the total moles of H2 gas which were being liberated, right? These were the total moles of H2 gas which were being liberated as per the equation. Can I say some part of H2 gas is getting liberated from reaction number 1 and some part of H2 gas is getting liberated from reaction number 2, right? If I use a concept like this, number of moles of H2 gas getting liberated from reaction number 1 plus number of moles of H2 gas getting liberated from reaction number 2 should be equal to the total moles of H2 gas which are getting liberated, right? As simple as that. So this is the concept which I'll be using. Now how will I be operating this concept? Have a look. Is the reaction balanced? The reaction is not balanced. Let's try to balance the reaction. There should be 2 times. I think the reaction is balanced, right? Yes, the reaction is balanced. Okay, right? If I make it as, just a second. If I make it as 3 divided by 2 times, or let me make it as 3 times, just a second. If I make it as 3 times, and I'll be making this as 3 by 2 times, I think that this reaction is balanced as well. Since I've balanced these 2 reactions, the reactions are balanced. Now have a look exactly. See, what is the stoichiometric coefficient over here? It's 1. What is the stoichiometric coefficient over here? It's 1. Can I say, as per this reaction, 1 mole of magnesium liberates 1 mole of hydrogen? As per the stoichiometry, 1 mole of magnesium liberates 1 mole of hydrogen, right? But in the container, do we have 1 mole of magnesium? We do not have 1 mole of magnesium. In the container, there are X by 24 moles of magnesium. If 1 mole of magnesium liberates 1 mole of hydrogen, can I say X divided by 24 moles of magnesium will be liberating X divided by 24 moles of hydrogen? So basically, these are the moles of hydrogen which are being liberated from reaction number 1. In the similar way, I'll be calculating the moles of hydrogen which are being liberated from reaction number 2, right? Have a look exactly. Stoichiometric coefficient over here is 1. Over here it's 3 by 2. Can I say 1 mole of aluminium liberates 3 by 2 moles of hydrogen, right? But do I have 1 mole of aluminium in the container? No way. I have got 1 minus X divided by 27 moles, right? So 1 mole of aluminium liberates 3 by 2 moles of hydrogen. So can I say 1 minus X divided by 27 moles of aluminium liberates 3 by 2 multiplied by 1 minus X divided by 27 moles of hydrogen. So these are basically the moles of hydrogen which are being liberated from reaction number 2, right? Okay. What about the total moles of hydrogen which are being liberated? These are the total moles of hydrogen which are being liberated, right? These are the moles of hydrogen liberated from reaction number 1. Moles of hydrogen liberated from reaction number 2. So can I say number of moles of hydrogen which are being liberated from reaction number 1 plus number of moles of hydrogen which are being liberated from reaction number 2. This should be equal to the total moles of hydrogen which are being liberated as per the equation. As simple as that, right? So what should I write over here? What should I write over here? I'll be writing something like this. Number of moles of hydrogen getting liberated from reaction number 1, which is X by 24, plus number of moles of hydrogen getting liberated from reaction number 2, 3 by 2 multiplied by 1 minus X divided by 27. This should be equal. Total moles of hydrogen liberated, which is 1.12 divided by 22.4. People, you got one equation which contains just one variable, right? Well, in the NEET examination, calculation is not going to be this much lengthy. Calculation part is going to be easy, right? But the concept can be same. The concept can be same, right? See, you got one equation containing one variable. While solving this equation, you can get the value of X. You can get the value of X. And as far as I remember, X value comes out to be something as 0.4. What was X basically? X, I had assumed the mass of magnesium in the container. So this is basically mass of magnesium in the container. Well, if you got the mass of magnesium in the container, you can calculate the mass of aluminium in the container as well, which was 1 minus X if you remember. So 1 minus 0.4 comes out to be 0.6 grams, right? So you exactly got the mass of magnesium and aluminium in the container, right? You guys can let me know in the chats if the concept is clear to you. Yeah? Let me know fast in the chats, my dear people, if the concept is clear to you. Perfect. I'm giving you one similar type of question as the homework. One similar type of question based on the same concept. Whatever steps we followed in this question, same steps you are going to follow in that question as well, right? But that's going to be your homework, right? You are going to try that question once the session ends, and you all are going to let me know the answer of that question in the comment section once the session ends, right? So let me show you that question. Let me show you that question. This is the question, similar type of question, right? Similar type of question. 1.67 grams of a mixture of aluminum and zinc reacted with HCl and liberated some 1.69 liters, it's not grams, sorry, 1.69 liters of H2 gas at STP. Calculate the mass of aluminum and zinc in the container, in the mixture, right? Same thing, same procedure you guys will be following, and you guys will be letting me know the answer of this question in the comment section, right? Let me move on to one more type of question based on the same mixture analysis, right? See guys, one more type of question, and this is something which I'll be showing you right here. Okay, why? Because I'll be using a different method to solve this question, and I want you guys to remember this method as well, which I'm going to show you now, right? See guys what the question says. Read the question carefully. Class 9, this is NEET session. What? 1 mole of N and 1 mole of N2 contains equal number of particles. What? Particles? You talking about molecules, atoms, or what? Mr. Legend, be careful, right? Be clear with the terms you are saying. Yeah. Arshad, in the last question, it was not, sir, the 1 gram in the previous one is of no use. In the previous one, 1 gram was of use because I assumed that let the mass of magnesium be X and the mass of aluminum be 1 minus X, right? Okay, let's have a look on this question, guys. Understand this question carefully now. A gaseous mixture of propane and butane. So we have got a gaseous mixture. We have got a container which contains propane and butane of volume 3 liters. So volume of the mixture is 3 liters. On complete combustion, it produces 10 liters of carbon dioxide at STP. Calculate the volume of propane and butane in the mixture. A similar type of question, but methodology will be different. You can use the same concept which I showed you a few minutes back, or you can solve the equation in a different way as well. Let me show you that way, simplest way of solving the equation, right? See guys, as per the equation, this is the container which is given to me. For example, in this container, we have got propane, C3H8, and with propane, you have got butane as well, right? Which is C4H10. So this is the gaseous mixture which is given to me as per the equation, right? What about the volume of this gaseous mixture? It is mentioned in the equation that the volume of gaseous mixture is 3 liters, right? Volume of gaseous mixture is 3 liters. 3 liters is the volume of gaseous mixture. So first of all, let's assume, before reading the equation, before doing the equation, let's assume out of the 3 liters of the mixture, let's assume there are some X liters of propane in the mixture. So the remaining is going to be 3 minus X. So there will be 3 minus X liters of butane in the mixture, right? There'll be some 3 minus X liters of butane in the mixture, as simple as that, right? The total volume of the mixture was 3 liters. So if this is X liters, this is going to be 3 minus X liters, as simple as that, right? Now, as for the question, we are doing the combustion of this mixture. We are doing the combustion of this mixture. So what does that mean? Basically, I'm making this mixture to react with the excess of oxygen. I'm making this mixture to react with the excess of oxygen, right? Yes, so what is going to happen? Combustion of this propane as well as combustion of this butane is going to take place. That's something which will happen, right? And combustion of hydrocarbon always leads to the formation of carbon dioxide and water. So how many reactions will be taking place over here? When we do the combustion of this mixture, so combustion of this propane and combustion of this butane will take place separately. Okay, so there'll be 2 reactions basically. There'll be 2 reactions basically. And as per the question, when we do the combustion of this mixture, 10 liters of carbon dioxide gets liberated. Volume of carbon dioxide getting liberated after the complete combustion of this mixture is equal to 10 liters, as per the equation itself, right? As per the equation itself. Now, how many reactions will be taking place? There will be 2 reactions. First reaction, this propane will undergo combustion. I'll make this propane to react with the excess of oxygen and it will lead to the formation of carbon dioxide gas, and with this you'll be writing water as well. So this is the first reaction which is going to take place over here. Similarly, what about the second reaction? The second reaction is going to be this butane is going to undergo combustion. And when butane C4H10 undergoes combustion, that means when I'll make it to react with the excess of oxygen, it will again lead to the formation of carbon dioxide, and with this you'll be writing water as well, right? These are the 2 reactions which are going to take place when we do the combustion of this mixture, as simple as that, right? What do we need to do now? Let's balance these two reactions. Let's balance these two reactions. And I've already shown you how to balance these two reactions, right? If this is 3 over here, I'll be writing 3 over here. If this is 8 over here, 8 divided by 2, that is 4, I'll be writing 4 over here. This is going to be x plus y by 4. 3 plus 8 by 4. 3 plus 8 by 4 comes out to be 5. This is a balanced chemical equation. In the last session, I told you exactly how to balance the combustion reaction. Now it's a balanced chemical equation. Point number 1. Point number 2. Let's try to balance this reaction as well. This is 4, so this should be 4 times. This is 10. 10 by 2 means 5 times. And this should be x plus y by 4. X is 4, y is 10 divided by 4. So this is 5 divided by 2. So 4 2s are 8. 8 plus 5 is 13. So this is 13 by 2. This is the balanced chemical equation. And the balancing of combustion reaction I've told you in the last session. I hope you remember that, correct? Since I've balanced both the reactions, what do we do? Understand now. What is the stoichiometric coefficient over here? It's 1. What about the stoichiometric coefficient over here? It's 3. What about the stoichiometric coefficient over here? It's 1. Stoichiometric coefficient over here, that's 4. Okay. First of all, as per the equation, when we do the combustion of this mixture, this is going to be the total volume of carbon dioxide which gets liberated. And during the combustion, how many reactions takes place? There will be 2 reactions taking place, right? Sir, not 5 times. Why it's not 5 times? Not 5 times oxygen. So x plus y divided by 4. 3 plus 8 divided by 4. It's 5 times only, right? Yeah? This is 3. This is 8 divided by 4. 4 1s are, 4 2s are, 3 plus 2 is 5, yes? Okay. See, so when we do the combustion of this mixture, as per the equation itself, 10 liters of carbon dioxide gets liberated. So how many reactions basically take place? 2 reactions. Can I say some volume of carbon dioxide will be getting liberated from this reaction and some volume of carbon dioxide will be getting liberated from this reaction? Okay. Can I say volume of carbon dioxide which gets liberated from reaction number 1 plus volume of carbon dioxide which gets liberated from reaction number 2 should be equal to the total volume of carbon dioxide liberated? This is the question this is the concept which I'll be using, right? This is the concept which I'll be using, as simple as that. Have a look exactly. Stoichiometric coefficient over here is 1, over here is 3. Now, as per the volume method, you can treat these stoichiometric coefficients as volume as well. In the last session I've told you, you can treat the stoichiometric coefficients as moles, you can treat the stoichiometric coefficients as volume as well. Can I say 1 liter of propane liberates 3 liters of carbon dioxide as per stoichiometry? 1 liter of propane on combustion liberates 3 liters of carbon dioxide. But in the container, do I have got 1 liter of propane? No. I have got some X liters of propane, right? Have a look. If 1 liter of propane gives 3 liters of carbon dioxide, can I say X liters of propane will be giving me some 3X liters of carbon dioxide? So this is basically the volume of carbon dioxide getting liberated from reaction number 1, right? Yes. Similarly, there will be some volume of carbon dioxide which will be getting liberated from reaction number 2, right? So can I say 1 liter of butane on combustion liberates 4 liters of carbon dioxide. If 1 liter of butane liberates 4 liters of carbon dioxide, in the container, am I doing the combustion of 1 liter of butane? No, we are doing the combustion of 3 minus X liters of butane, right? Okay, so if 1 liter of butane liberates 4 liters of carbon dioxide, I'll say 3 minus X liters of butane will be liberating 4 multiplied by 3 minus X liters of carbon dioxide. So basically, I got the volume of carbon dioxide which gets liberated from reaction number 2, right? When we do the combustion of this mixture, these were the 2 reactions which happened to take place. So from both the reactions, there was some amount of volume of carbon dioxide which used to get liberated. So volume of carbon dioxide which gets liberated from reaction number 1 plus volume of carbon dioxide which gets liberated from reaction number 2 should be equal to the total volume of carbon dioxide which gets liberated as per the equation, right? Yes. So I'll be simply writing one equation. Where do I write the equation? The equation I'll be writing over here. Volume of carbon dioxide which gets liberated from reaction number 1, which is 3 times X, plus volume of carbon dioxide which gets liberated from reaction number 2, which is 4 times 3 minus X. Right? This should be equal to the total volume of carbon dioxide liberated as per the equation, that is 10, right? Now do a bit of calculation and kill the equation, right? Have a look. it's going to be simply 3x plus 12 minus 4x is equal to 10, right? So the x value will come out to be 2. What was x basically? X, I had assumed the volume of propane in the mixture. So I got the volume of propane in the mixture as 2 liters. And if there are 2 liters of propane in the mixture, you can say there will be 3 minus x, 3 minus 2. That means 1 liter of butane will be there in the mixture, right? You guys can let me know in the chats if it is clear to everyone, if you got the concept properly. Yes? Let me know first in the chats if this concept is clear to everyone. If anyone has got any sort of doubt, you can just use your common sense a bit, right? It's not an offline class going on, correct? Just drag the video a little back. It'll be automatically a replay for you. There is no need to repeat again, correct? That is the benefit of the online classes. If you're not using the benefit of the online classes, then there won't be no difference. There'll be no difference between the offline and online, right? Yes? So just whenever you feel difficulty in understanding any concept, in understanding any procedure, any problem, just drag the video a little back. It'll be automatically a replay for you, yeah? Okay, so let's move on then. Should we move on, guys? Should we move on? Give me thumbs up in the chats fast. Give me some thumbs up in the chats if you want me to move on. Yeah? That's great, Ritik. Okay. All right. Now people, let's move on then. And let's try to understand one more concept in the stoichiometry, right? See, I told you first of all, in the stoichiometry, whatever method you are using, the first step always is going to be the balancing of the reaction, right? That's the first step which you do in every equation based on the stoichiometry, right? You balance the reaction. Now, there will be certain reactions which you won't be able to balance, right? There will be certain reactions which you won't be able to balance. Yes, there will be certain reactions which will take time to balance, correct? For those reactions, we prefer POAC method. We prefer POAC method, right? Which is principle of atom conservation. So where do we use this POAC method? I'm not going to use this POAC method all the time in all the equations. No way. No way. I'm going to use this POAC method in those reactions which we won't be able to balance, which are really difficult to balance, right? Which cannot be balanced, right? In those equations, in those reactions, I'll be using the principle of atomic conservation method, right? Okay, so let's see exactly the principle of atomic conservation method and how do we exactly solve the equations by means of this POAC method, right? See guys, for example, I'm taking a general reaction. I'm taking a general reaction, correct? Let's say I'm taking a general reaction like, let me make it like this. A10, B20 plus B2, C5. It gives, for example, it gives A4, C10 plus B5, D4. Let's assume this is one reaction which I'm writing. This is one general reaction which I'm writing. This is one general reaction which I'm writing. First of all, if I ask you, can you balance this reaction? Can you balance this reaction? You cannot balance this reaction. You won't be able to balance this reaction, right? Yes? Correct? So whenever you cannot balance a reaction, whenever it will be difficult to balance the reaction, at that time, we solve the equation by means of POAC method, by means of principle of atom conservation, right? Now let me show you exactly how to use the POAC method in the equations, right? But before showing you that, let me show you how do we make the POAC equations. Let me show you exactly how do we make the POAC equations, right? See guys, exactly how do we make the POAC equations. Understand this, then we can do the equation and we'll solve the equation in lesser time. Have a look. For example, I need to write the POAC equation for atom A. Let's say I need to write the POAC equation for atom A. First of all, the first benefit for using POAC is we are not supposed to balance the reaction. In POAC, we are not supposed to balance the reaction, right? After that, you will be writing the POAC equations. Now, for example, I'll show you how to write the POAC equation for atom A, right? First of all, this is one of the reactant. Do we have A in this reactant? Yes, we have A in this reactant. How many atoms of A do we have? We have 10 atoms of A, right? So I'll be writing 10 multiplied by number of moles of this whole compound. Number of moles of this whole compound, which is A10, B20. Do we have A over here? We do not have A over here. So I've got nothing to do with this, right? Instead of this arrow, I'll be using equal to sign, right? Do we have A over here? Yes, we have A over here. How many atoms? 4. So I'll be writing 4 multiplied by number of moles of this whole compound, which is A4C10, right? Do we have A over here? No, there is no A over here. So I've got nothing to do with this one as well. So this is one POAC equation in terms of atom A, right? Yes. Similarly, you can write the POAC equation for atom B as well. You can write the POAC equation for atom B as well. Have a look. Do we have B right here? Yes, we have got B. And how many atoms of B we have? We have 20 atoms of B. So I'll be writing 20 multiplied by number of moles of this whole compound, which is A10, B20. Do we have B over here? Yes, we have B over here. And the sign in the middle is plus, right? How many atoms of B? 2. So 2 multiplied by number of moles of whole compound. Number of moles of B2C5. Instead of this arrow, I'll be using the equality, right? Over here, do we have B? No. We have B over here, and how many atoms? 5. So 5 times number of moles of this whole compound, which is B5D4. This is one complete POAC equation in terms of atoms B, right? So I think you got to know exactly how do we make the POAC equations, right? Yes? Right, people? What is the full form of POAC? It is principle of atom conservation. Principle of atom conservation. You got to know how to write the POAC equations? Yeah? If you got to know how to write the POAC equations, let's try to solve the questions which are based on the POAC. Right? Have a look exactly. The first and the common question which is asked, which we can solve by means of POAC. It's a very, very common question. This question you'll get in almost all the books, right? This question you are going to get in almost all the books, correct? Look at the question and see what the question says. As per the question is concerned, have a look. It's mentioned that 27.6 grams of K2CO3, 27.6 grams of K2CO3 was treated by a series of reagents. You have no idea what these reagents are, right? 27.6 grams of K2CO3 was treated by a series of reagents so as to convert all its carbon to K2ZN3 FeCN6 whole twice. Calculate the mass of the product formed. You need to calculate the mass of the product formed. You need to say exactly how many grams of this product got formed, right? This is the product which we have. You need to calculate its mass. Look at the question carefully. 27.6 grams of K2CO3 was treated with a series of reagents so as to convert all its carbon to K2ZN3 FeCN6 whole twice, right? What is the mass of the product formed? People, is this a complete reaction or incomplete reaction? You have no idea what are the other reagents with which this K2CO3 is reacting, right? You have no idea what are the other reagents. So can you balance this reaction? You won't be able to balance this reaction. And if you cannot balance the reaction, which method do we use? POAC method, as simple as that, right? POAC method you guys are going to use. And in the POAC method, what do we do? Are we supposed to balance the reaction? No way. Right? What do we do in POAC? We make POAC equations. We make POAC equations, right? Now, for which atom am I going to use POAC? For which atom am I going to make the POAC equation? Is it going to be K? Is it going to be carbon? Is it going to be oxygen? For which atom am I going to use the POAC equation? Now see, which atom is common among the two? Which atom is common among the two? Potassium, potassium. Potassium is common among the two. At the same time, this is carbon, this is carbon. At the same time, carbon is common too. So there are two atoms basically. There are two atoms which are common. One is potassium, one is carbon. Now, am I going to make the POAC equation for potassium or carbon? Understand. There is a hint given in the question. 27.6 grams of K2CO3 was treated with a series of reagents so as to convert all its carbon. So whatever carbon was there in K2CO3, that is getting entirely converted into the product. So can I say carbon atom is remaining conserved in the reaction? Can I say carbon is remaining conserved in the reaction? And that atom which remains conserved in the reaction, for that atom only, we actually write the POAC. Yes? So let's write the POAC equation for the carbon atoms, as simple as that, right? So POAC equation for carbon, what is it going to be? Do we have carbon right here? Yes, we have got carbon right here. How many atoms? 1. So 1 multiplied by number of moles of K2CO3, right? We have no idea what this ABC are. Leave it, right? Instead of this arrow, I'll be using the equality. Do we have carbon over here? Yes, we have carbon. How many atoms? 6 multiplied by 2. So there are 12 carbon atoms. So 12 multiplied by number of moles of this whole compound. So I'll say number of moles of the product, right? So can I say you got an equation which contains 2 unknowns. What are the unknowns? First unknown is number of moles of K2CO3. Second unknown is number of moles of product. But I can calculate this one. I can calculate number of moles of K2CO3 because mass of K2CO3 is given to me, right? I can calculate number of moles of K2CO3, which is going to be equal to mass of K2CO3, that is 27.6 grams, divided by molar mass of K2CO3 is 138. So these are the moles of K2CO3, right? So can I say number of moles of product is going to be equal to number of moles of K2CO3 divided by 12. We got to know the number of moles of K2CO3, that is 27.6 divided by 138, and in the denominator you have got 12, right? So these are basically the moles of the product. These are the moles of the product which got formed at the end of the reaction. But was I supposed to calculate the moles of product? No, I was supposed to calculate the mass of product. How do we convert moles into mass? How do we convert moles into mass? I'll be writing mass of the product formed will be equal moles of the product formed, which is 27.6 divided by 138 multiplied by 12 multiplied by molar mass of this product. What is the molar mass of this product? When you calculate it, it will come out to be 698 grams per mole, right? And when you solve this, this is going to give you the mass of the product formed, which gets formed at the end of the reaction. You guys can let me know in the charts if it's clear. Well, Ishpreet is saying the answer comes out to be 11.168. So it is 11.168 grams. So finally you got to know 11.168 grams of product are getting formed at the end of the reaction. Well, this is the first application of what? This is the first application of POAC. Whenever you won't be able to balance the reaction, right? Or it's going to be difficult to balance the reaction. At that point of time, you're going to use the POAC method, right? And in this POAC, you're not supposed to balance the reaction. You'll be simply writing the POAC equation for that atom which remains conserved in the reaction. For that atom which remains conserved in the reaction, right? Yes? Right, people? Perfect. Should I be moving on? Someone is saying just teaching, not solving problems. So is this theory going on? I never knew this is theory, bro. Thanks for letting me know. This is theory. Yeah? Okay, so let's move on. This is one more type of question in which we are going to use the POAC, right? Yeah? This is one more question in which I'll be showing you how to use the POAC method, right? First of all, these are the set of reactions which are given to us, right? These are the set of reactions which are given to us. So I'll be calling these sort of reactions as sequential reactions, right? What are sequential reactions? I'm sure you would have studied chemical kinetics. In chemical kinetics, you talk about 2 types of reactions: elementary reactions, complex reactions. Complex reactions were, that was multi-step reactions, right? Okay, they take place in a sequence. For example, I've got a reaction like this: A plus B gives C plus D, right? Let's say this C plus D again gives some E plus F. Let's say E reacts with some G, forms H and I, right? When I add them up, what all things get cancelled out? CC, DD gets cancelled out, E gets cancelled out, right? So what is going to be the net reaction? The net reaction is going to be A plus B plus G gives what? F plus H plus I. If I ask you, is this reaction taking place in one step? This reaction is not taking place in one step. This reaction is taking place in a series of steps, and any reaction which takes place in a series of steps, we call that reaction as the sequential reaction. We call that reaction as the sequential reaction, right? Now, do we have the sequential reactions over here? Have a look. Calcium carbide, CaC2, is reacting with water. It's forming CaO plus C2H2. Now, this C2H2, which is the product in the first reaction, It is participating in the second reaction. It becomes the reactant in the second reaction. Now the product which is formed in the second reaction, which is C2H6, C2H4, which is C2H4. This C2H4, which is the product of the second reaction, it becomes the reactant of the third reaction. So we have got the sequential reactions. And in the sequential reactions, you can use the POAC method. You can solve the equations, right? And how do we approach this sort of equation? Understand. See guys. See exactly what we are going to do. First of all, understand. Calculate the mass of polyethylene that can be produced from 10 kilograms of calcium carbide. So I'm starting with 10 kilograms of calcium carbide. So first of all, which I'll be doing, what is the first thing which I'll be doing? I'll be converting the given mass of the substance into its number of moles. I'll be calculating the number of moles of calcium carbide. It's going to be equal to given mass of calcium carbide in grams divided by molar mass of calcium carbide, which is 64. So these are the moles of calcium carbide which we have. These are the moles of calcium carbide which we have. First thing which I did, right? Now, after calculating the moles of calcium carbide, let's exactly see. We have got CaC2. It's reacting with H2, right? We get calcium oxide and C2H2, right? So there were two carbon atoms over here. There are two carbon atoms over here as well, right? This is C2H4. There are two carbon atoms over here. There are two carbon atoms over here as well, right? In this reaction, we have got two N carbon atoms. Over here, again, we have got two N carbon atoms. So can I say carbon is remaining conserved over here? In this set of reactions, which atom is remaining conserved? Carbon is remaining conserved, right? Carbon is remaining conserved. How do I solve this sort of equation? Understand properly how do I solve this sort of equation? Mass of calcium carbide is given to us. Mass of polyethylene we need to calculate. Mass of calcium carbide is given to us. Mass of polyethylene which is something which I need to calculate. So out of all the things, I'll be only writing calcium carbide on one side. On other side, I'm writing polyethylene. And this is polyethylene, C2H4N, right? This is polyethylene. So out of all the things which were given to us, I just wrote the substance whose mass was given to us and the substance whose mass I'm supposed to calculate. I just wrote these two things. Now if I ask you, which atom is common among the two? Carbon is common. If carbon is common, I'll be making the POAC equation for carbon atoms. How many carbon atoms do we have here? 2. So I'll be writing 2 multiplied by number of moles of CaC2, number of moles of calcium carbide. Instead of this arrow, I'll be using the equality, right? If I ask you, how many atoms of carbon do we have? Do we have 2 atoms of carbon or 2 N atoms of carbon? We have 2 N atoms of carbon. So I'll be writing 2N multiplied by number of moles of this whole compound. Number of moles of whole compound means number of moles of polyethylene, right? So I can write something like this. 2 multiplied by number of moles of calcium carbide we have already calculated, that is 10,000 divided by 64 is equal to 2 multiplied by N multiplied by number of moles of polyethylene. Can I say 2 gets cancelled out first of all? So I got the number of moles of polyethylene which came out to be 10,000 divided by 64N. These are the moles of polyethylene which got formed. These are the moles of polyethylene which got formed. But were we supposed to calculate the moles of polyethylene formed? No way. We were supposed to calculate the mass of polyethylene formed. How do we convert moles into mass? How do we convert moles into mass? I'll be writing mass of polyethylene which gets formed at the end of the reaction will be equal to moles of polyethylene formed, which is 10,000 divided by 64N multiplied by molar mass of polyethylene. What is the molar mass of this polyethylene? Carbon 2. That means 12, 12, 24. 24 plus 4 comes out to be 28. Is 28 grams going to be molar mass of polyethylene or 28N is going to be the molar mass of polyethylene? I'll say 28N is going to be the molar mass of polyethylene, right? Do not skip this N over here. Can I say this N gets cancelled out? So I'll be finally getting the mass of polyethylene which gets formed at the end of the reaction, which is 10,000 divided by 64 multiplied by 28. So solve this and get the value in grams. So this is basically something which I was supposed to calculate and people are coming up with the answers. It is 4375 grams. So finally you got to know 4375 grams of polyethylene gets formed at the end of the reaction. People, is this clear to every single guy? Let me know fast in the chats. Let me know fast in the chats if it is clear to every single guy. Correcto? Right? Perfectly done. Wonderful. So I'm sure you got to know how to use the concept of POAC, right? So there is one topic left, limiting reagent, and I think limiting reagent we are going to start day after tomorrow, which is our next session, correct? On Saturday, right? Because if I start this limiting reagent now, it won't get completed, so this concept will go in vain. I don't want to make that happen because this is again one of the most important concepts which almost you use in all the chapters of your physical chemistry, right? So let's do this limiting reagent. So let me first of all tell you what all things we are going to cover in the next session. In the next session, we are going to talk about the limiting reagent concept. We'll be talking about the percentage yield of the reaction. We'll be talking about the percentage purity of the reaction. These are again the three important topics which we are going to cover in the next session, which is going to be there on Saturday at 8 p.m. Right? Saturday at 8 p.m. sharp, we are going to start it, yeah, on the same channel. And the ones who have not liked the video yet, please do like the video, share the video with friends, and do not forget to subscribe the channel as well, okay? So it was nice meeting you. The questions which I've given you as the homework, please and please do solve those questions, right? 2 questions I think I've given as the homework, right? Yes, so do solve those questions and let me know the answers of those questions in the comment section, right? And do let me know one more thing, after this chapter, which chapter you want the next, right? Do let me know that as well in the comment section, okay? Perfect. So let's stop with this. Rest we'll be doing in the next session, which is there on Saturday. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye. And be consistent for the classes, right? Take care. Bye-bye.